Hey guys, here is a quick video to show you and give you some hints on how to work on 5VF in iXL. Okay? 5VF, that's what I want you to practice. You are here. We're looking at, let me get my annotate, 5VF. So remember, when you get into iXL, you just type 5V as in Victor, F as a Frank, and you put that in this little search bar, click enter, it'll take you over here so you can practice writing variable expressions for arithmetic sequences. So this is how you do it. This is the way I do it. You could probably figure out a different way to do this, but the first thing I want to say is like, look, this is a sequence, okay? So it is a specific set of numbers. It's in order. It's got a starting point, and the starting point is the number 70. And you can write this out as a sequence, like vertically, like how they've done it right here. So you can go 70, 71, 72, 73. This dot, 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 this ellipse means it keeps on going forever. Okay, so dot, dot, dot equals goes on forever. It's called an ellipsis, an ellipse. But it starts at 70. It doesn't start at 69. It doesn't start at 68. It starts at 70, and then it goes on forever. But the first thing I notice is the common difference of 1, right? That's my common difference. And then the other thing that I want to notice about this is they're saying use n to represent the position of the term in the sequence where n equals 1 for the first term. And what they mean by this is if I were going to make a table, and again, this is all in order. So I've got 70, 71, 72, and 73. I know that I'll put the term over here and the number over here. This is the first term, the second term, the third term, and the fourth term. So term just means the specific order of the number. Specific order. The first one is 70. The second one is 71. The third one is 72, so on and so forth. So now, let's take, instead of the number 1, the number 2, or the number 3, we're going to start to replace this with n and see what happens. So what if this were an n, okay? So n in the first term has to get you to 70. You have to do something to n to get you to 70. Let's just say n plus, let's see, if n were 1, we know n equals 1 in this case. If I had 69 plus 1, I would get to 70. So now if I change this 1, and I know this is the 1 from here, and I exchange that for n, 69 plus n would get me to 70. The second term is 2, so if n equals 2, 69 plus 2 would get me to 71. So I think I've got it. 69 plus 3 would get me to 72. So I'm starting to figure out how, if I replace each of these terms, 1, 2, 3, 4, with a variable n, and I add it to the number 69, I will always get this number. And as you work on 5VF, the one thing that they want you to do is they want you to put the n, the variable, first. So when I put in my answer, I'm going to do, instead of 69 plus n, what I did here, I'm going to do n plus 69 as my answer. So let's see what happens. N plus 69, n plus 69. Oh, let me happen to my keyboard. Let's delete this. I'm going to use lowercase n, sorry, n plus 69 Do I have success? Good work. I'm ready at 10. Now I've got negative numbers. I'm going to do the same thing. I am going to make a table. I'm going to make this extra long. And I'm going to do a couple of things. So one, I'm going to do the term. And then I'm going to put the number of the sequence. So 1, 2, 3, 4. They give me 4 numbers. It's negative 49, negative 98, negative 147, negative 196. And I'm going to put in this third column my check. And I'm going to use substitution to check. So if I look at these numbers, again, I think I'm going to look for a common difference. And I can see that the common difference here looks to be negative 49, right? Negative 49 plus negative 49 gets you negative 98. Negative 98 plus negative 49, you're getting more negative. So your negative is increasing. It is a common difference of negative 49. Same thing for the third and fourth terms. So I see a common difference of negative 49. It's also starting at the number 49. So in my head, I'm actually already thinking this just looks like multiplication. So negative 49 times n would probably do it for me. And if I use substitution to check, if I take each of these terms, remember n equals the term, and here are your terms, 1, 2, 3, 4. If I use substitution to check, I'm going to be able to check to see if my answer really works. So I'm going to use the blue now. So I think my expression is, let's draw this, get me this pen, negative 49 times n. Well, I don't even need a parentheses. Undo. Negative 49 times n. So for the first term here, negative 49, and I substitute this 1, I bring it all the way in, I substitute it for n, times 1 gets you negative 49, so that works. So for the second term, negative 49 times 2, I substitute that in, gets me negative 98, that works. The third term in the sequence is 3, so negative 49 times 3. I multiply those together. 3 times that is 7, carry the 2, that's 147, negative, a negative times a positive is a negative. So this is starting to work out for me, right? I'm feeling really good. So I'm going to take my expression, negative 49 times n, and I'm going to put it in right here. And let's see what happens. Let's turn off my annotation, go negative 49n. Negative 49n. Let's see if I need the multiplication sign or if this just works. Enter. Oh, incorrect. What happened? Let's see. I was so positive. So I'm going to go and erase all my annotations here, clear all my drawings. Okay, now I like this. I like that I got it wrong because now I can go through and read the explanation. So sorry, incorrect. The correct answer is negative 49n. I thought that's what I put in. Oh, I answered down here. They told me I put negative 4n, so I forgot to type in that 9. But you guys all saw from the previous thing that I had negative 49. I did it right? Okay. So anyways, I got it right. I like that I can review this. I like that I further go down and they explain it to me. So when you know, one thing I see a lot of people doing on iXL is they get it wrong and they don't read the explanation. Okay, they just click forward and want to try another problem. Take your time and read this explanation. It explains to you the sequence, right? And they're showing you the substitution. Again, I use a table so that I can lay it out, the terms 1, 2, 3, 4. and then the numbers, and then I look for the common difference, and then I come up with an expression, and then I use substitution to check. But this is a good way to do it as well. Please let me know if you have any questions. This is a 10-minute video showing you how to do 5VF arithmetic sequences and writing variable expressions. Good luck.